Okay, so what we want to do now is to show that this argument is invalid. And notice it has all universal quantifiers. So when you have a universal quantifier in the conclusion, it's making a demand on you to put something in your universe to make it false, because it's saying every object has this property. So you have to put an object in here which doesn't have this property. And since it's a horseshoe, there's only one way to show it doesn't have that property. Give it squiggle G and E. So I put an object in here with squiggle G and E, and it makes the conclusion false. Why? Because this object makes that false. It's a horseshoe, and if the left-hand side is true and the right-hand side is false, the horseshoe is false. So the left-hand side is true, the right-hand side is false. So this object doesn't have this property. And since there is an object that doesn't have this property, it's false that every object has the property. So we took care of that. Now, as I said, when there's a universal quantifier in your premises, you do those last. You do those last. And now we have two universal quantifiers. Each have horseshoes. This says everything, if it has F, then it has G. Well, this object has not G. So if we put F on this object, we would make that false. So we have to put not F on that object. Since this object does not have F, this horseshoe is true of it, because a horseshoe with a false left-hand side is true from the truth table for the horseshoe. Now what about the second premise? It says if you have not F, then you have E. This has not F and it has E. Now let's just confirm that both of these premises are true. This first premise says every object in the universe is such that it has this property. If it has F, then it has G. So here is one object in the universe. It has not F, thus making that horseshoe true of it, because a horseshoe with a false left-hand side is true. Since it's the only object in here, that means every object in our universe has this property. Now let's look at the second premise. It says if you have squiggle F, then you have E. So this object has squiggle F and it has E. So this object, this one object, makes that true. It has that property. But now, this says every object has to have this property. But that's the only object in the universe, so that's true. Every object does have this property. Thus, premise 2 is true and premise 1 is true. And so we've shown that that's true, that's false, and thus this shows the argument is invalid. And we satisfied the requirement that every object we put in our universe has each property or its negation. There are three properties, F, G, and E, and this object has each property or its negation. So this is a good answer. And we didn't have to know what that is, nor what these mean. And we're done.